All right, so we're going to look at compound interest. So here we have an example. It says find the accumulated value of an investment of $15,000 for 4 years at an interest rate of 6% if the money is A, compounded semi-annually, B, compounded quarterly, C, compounded monthly, D, compounded continuously. So we are going to work this word problem. But before we do this, what is compound interest? Okay, compound interest is interest computed on your original investment as well as on any accumulated interest. So there are four parts to this question that they're asking us to find the accumulated value. What would be um, money that you invested? Let's say you invested $15,000 for 4 years, and this would be your interest rate. You know, what happens if you um, invested it twice a year, 4 times a year, or every month, or continuous, compounded continuously? Okay, continuous means every month, okay, or every pay period, okay, but forever and ever. So let's look at what we have here. It says if compound interest is paid twice a year, we say that the interest is compounded semi annually. If compound interest is paid 4 times a year, we say that the interest is compounded quarterly. And lastly, if the number of compounding periods increases infinitely, okay, we call this continuous compounding. Okay, so twice a year, semi-annually, 4 times a year, quarterly, compounding periods increases infinitely. We call that continuous compounding. All right, so there are two formulas that we would need. There's one for whenever you're given the n periods, okay, number of times the interest is compounded per year. So this is our formula. A is equal to P times 1 plus R over N, all raised to the n times t. So this kind of goes hand in hand with the exponential functions and as well as the natural base e function. Um, so let's look at each part where A represents the amount, the the future value of the investment loan including the interest. What would you get after in this question that I had posed at the beginning of the video? Okay, what will be your final investment after 4 years, the total amount with the interest and what you invested? Okay, P is the principal invested amount, the initial deposit or loan amount. R, which is our rate, the interest rate, the annual interest rate, and we're going to represent the rate as a decimal. N represents the number of times interest is compounded per year. And then T, which is time, we represent that as years, the number of years the money is invested or borrowed for. Okay, so this is when we have N, the number um, of times interest is compounded per year. Is it semi-annually? Is it quarterly? Is it yearly? Is it monthly? Okay. Now for continuously compounding, here's the formula that we would use. And because E is a never-ending number, since it's continuous and E is infinite, well, E is part of the formula. We have A is equal to P times E raised to the R times T. A still represents the amount, P still represents the principal, R represents the rate, T is the time, and then E is the mathematical constant. All right, so let's do the first example. It's noted here. Find the accumulated value of an investment of $15,000 for 4 years at an interest rate of 6%. Okay. Part A. If the money is compounded semi-annually. Okay, so what will we have to do here? Okay, so of course we're going to be using A is equal to P times 1 plus R over N, all raised to the N times T, because it's giving us the number of compounded interest per year. Okay, so what do we have here? What is given? P, the principal, which is $15,000. Your N, the first example, we'll put part A, and our end here is going to be for semi-annually is going to be 2. Okay. T, how many years? 4 years at a rate of 6%, and we're going to convert 6% to a decimal, so we have 0.06. Okay. All right. So let's plug this information. Let's find how much money you would receive after 4 years investing $15,000. So we have here a total of $15,000. We have A is equal to 15,000 times 1 plus our rate 0.06 divided by our compounding semi-annually, so which is twice, all raised to the n times t, so 2 times 4. So let's go ahead and work this one out. We have here 15,000 times 1 plus. I'm going to bring the calculator up here. Let's divide 0.06 by 2. So 0.06 divided by 2, which gives us 0.03, all raised to the 2 times 4, we would say 8. Now this time, all we're doing now is using order of operation to simplify this. So next, we're going to add 0.03 to 1, which is 1.03, all raised to the 8th power. So I'm going to put plus 1 here. And then since we're saying 15,000 times this 1.03 raised to the 8th power, let's go ahead and raise the 1.03 to the 8th power. Press enter. Please do not round until the final answer. Okay, so we have here 1.2667700081, and then we're going to times that to 15,000 to find our value. Enter. And we're going to round to the nearest cent, so that means 2 decimal places. Okay, so for 15,000 4 years at 6% interest, you will have $19,001.55. So That is part A. That's semi-annually. So that's twice a year that you're putting money into your account for 4 years. It totaled to be $15,000. Now, what if we compounded quarterly? We put money in 4 times a year. Okay. Everything else stays the same with the exception of N. So we have A is equal to 15,000 times 1 plus 0.06 divided by 4, all raised to the 4 times 4. Okay, so I'm going to clear my screen. And we have 15,000 times 1 plus, let's do 0.06 divided by 4. That gives us 0.015 raised to the 4 times 4, so that is 16. Then we're going to add 0.015 to 1. That will give us 1.015 raised to the 16th power. So let's put plus 1, enter, which we verified that. Now, let's raise that to the 16th power. Here's our exponent key that I'm pointing to, and let's put in 16. So 15,000 times 1.2689,85548. Okay, and then times that to 15,000. So what happens if you invested your money 4 times per year, that's quarterly, and after 4 years you invested $15,000. So with and you're earning interest at 6%. So you will have 19,034 point, let's write this out, 78321. So you will have $19,034.78 at the end of 4 years. Okay, let's look at compounding monthly. So when we say compounding monthly, what we mean is what? How many months in a year? 12. Okay, so the number of compounding periods when it's monthly is going to be 12. So we have here, this is part C, N when N is 12. Okay, so we have here A is equal to 15,000 times 1 plus, we have 0.06 divided by 12, all raised to the 12 times 4. So let's go ahead and divide 0.06 by 12. So 15,000 times 1 plus, and let's clear the screen here. And we have 0.06. Let me clear this again. Sorry about that. Okay, we don't want that to happen. All right, here we go. 0.06 divide by 12. I don't know what just happened here. Okay, 0.06 0.06 divide by 12. We have 0.005, all raised to the 12 times 2, which is 48. Okay. Add 0.005 to 1. We have 15,000 times 1.005 raised to the 48th power. So let's add 1. And then we're going to raise that to the 48th power. So we have here 15,000 times 1.270489161, and times that to 15,000 to see if we would earn a little bit more if we invested monthly. So we have here 19,057.33742. So investing monthly, once a month, for 4 years, it was a total of $15,000 at a 6% interest rate. You would have at the end of 4 years 19,057.33. Okay. And then lastly, compounded continuously, we're using the formula, okay, which is A is equal to P times E raised to the R times T. So our principal is 15,000 times E raised to the R. What is our rate here again? 0.06. And our time, 4 years. So we have 15,000 times E raised to the, so let's multiply 0.06 to 4. That's 0.24 as our exponent. All right, so how would I put this in the calculator? This is how I would do it to make it work and make it easy for us. Now, if you notice, you have your LN button. I'm pointing to it with the cursor key. Above that, you have the e to the x. So let's go second e to the x, and you can do second and then your negative key, or we can just put in the exponent, which is going to be 2.24. Let's press enter. So we have 15,000 times 1.27124915, and then times that to 15,000. Okay. And we have, what will we have after 4 years? $19,068.74. There we go. All right, so we've looked at all 4 problems. Okay, and just to recap, okay, we talked about principal and rate. A sum of money is called the principal, is invested at an annual percentage rate we call R in decimal form, compounded once a year. The different types, we have compounded semi-annually twice a year, compounded quarterly 4 times a year. In compounding periods, it may even tell you how many compounding periods in the question. It may tell you what is in, so you would use that. And then when we have compounding periods increasing infinitely, we call that continuous compounding. And what does semi-annually mean? Twice a year, every 6 months. Compounding quarterly, 4 times a year, every 3 months. And then monthly compounding every month, well, 12 months out of the year, that will be every month.